Sine theta, cos theta, tan theta. What do these words mean and why are we bothered about them? You may have memorized various relations involving these trigonometric ratios, but if your concept is not clear, you will be weakening your foundation because trigonometry is essential for calculus, vector, and other topics needed for advanced physics and mathematics. In this video, we will learn about the basic terms. Then we will understand what is the meaning of trigonometric ratios such as sine theta or cos theta and what is their meaning. We will end the video with a mnemonic to memorize these results. Let us consider a right angle triangle ABC where the angle B is 90 degree. In this triangle, the other two angles will be acute, that is less than 90 degree, because the sum of the internal angles for a triangle must be 180 degree. The largest side of a right angle triangle is called the hypotenuse and it is the side opposite to the angle 90 degree. Let us choose any one of the remaining two angles, say angle A. In trigonometry, we often use Greek letters to name angles. So let us call this angle A as theta. We will be using the term angle A or angle theta and they will mean the same thing. This angle is formed by two arms AB and AC. AC is the hypotenuse, the side AB is next to angle A, so we can call it the side adjacent to angle A. The side BC is opposite to angle A. In short, AB is called the adjacent and BC the opposite. But remember, these terms are relative to the angle chosen. To understand this, let us draw another triangle ABC and this time we choose the angle C. Let us call this angle as phi. Now the side adjacent to angle C is BC and the side opposite to it is AB. If you compare the two triangles, then the side hypotenuse is the largest side and it is unchanged in both the diagrams. But the adjacent and opposite depends upon the choice of the angle. You must be extra careful while identifying the opposite and the adjacent. Some people like to call them the base and perpendicular, but these terms can be misleading, especially if the perpendicular is horizontal and the base is vertical. So it is better to stick to the terms adjacent and opposite. Now that you have learned to identify the sides, let us proceed to the trigonometric ratios. In a triangle, if you choose any two sides and find the ratio of their length, then the ratio remains constant as long as the angle does not change. To understand this, let us take a triangle ABC. Say with sides AC is equal to 5 cm, AB is equal to 4 cm and BC is equal to 3 cm. Now choose any two sides, say BC and AC, and find their ratio. So BC by AC is equal to 3 by 5 is equal to 0.6. Now without changing angle A, make the triangle bigger. We can do this by extending AC to E and AB to D. So we have a bigger triangle ADE. Angle A is the same as before. Now if you measure the length of the side DE and AE and find their ratio, then once again it will come out to 0.6. If we decrease the side of the triangle, then also the ratio GF and AG will be 0.6. This is true for a triangle of any size as long as the angle does not change. So what we have just found is opposite by hypotenuse is equal to constant. But this result is not true only for opposite and hypotenuse. This is true for any two sides of a triangle. So if we choose adjacent and hypotenuse, then will also be constant but different from the previous two ratios. Now if we choose opposite and adjacent, then we are getting opposite by adjacent is another constant. These ratios are very important and they have been given special names. Opposite by hypotenuse is called sine of angle theta. Adjacent by hypotenuse is called cosine of angle theta, and opposite by adjacent is known as tangent of angle theta. In short, we call these sine theta, cos theta and tan theta. Just remember OAO, ha ha ha, and play tic-tac-toe with it. That is, you draw the grid of tic-tac-toe. In the first row, you write S for sine, C for cos and T for tan. In the second row, you write OAO, and in the third row, you write HHA. Now, if you take the first column, you will get SOH, S-O-H, S for sine. So, sine theta is equal to opposite by hypotenuse. The second column will give you CAH, that is cos theta is equal to adjacent by hypotenuse, and the third column will give you TOA, tan theta is equal to opposite by adjacent. Some people simply like to remember the chant or mantra SOH-CAH-TOA. So if you remember SOH-CAH-TOA or OAO HHA, you are getting the same results. You can choose whatever suits you best. There are three more ratios: hypotenuse by opposite, which is called cosec theta; hypotenuse by adjacent is called sec theta; and adjacent by opposite is called cot of angle theta. If you compare these three ratios with the previous one, you will find cosec theta is equal to 1 by sine theta, sec theta is equal to 1 by cos theta, and cot theta is equal to 1 by tan theta. In case you are getting confused, just remember the left hand side and the right hand side cannot start with the same alphabet. So, if it is cosec theta, then the right hand side must be 1 by sine theta. It cannot be 1 by cos theta, because in that case the left hand side and the right hand side both will start with C. So, that is the simplest way to remember the relation between sine, cos, tan and their reciprocals cosec, sec and cot theta. In the next video, we will learn to use these ratios and we will try to discover how much information is encoded in these ratios.